What's up, Science Warriors? Guys, welcome back again. We're going to start our next flipped video here in our 6th grade science classroom. Today we're going to be talking about metals, nonmetals, and metalloids, TEAC 6.6a. And our essential question for this is going to be how are physical properties of matter used to classify elements into their three main groups. So let's get started then real quick. On your next blank page in your journal, I want you to create Cornell notes. So take a moment, pause the video, create your template, but also write your EQ at the top. Alright, so let's just jump into everything. So there are three main groups of elements. We have the metals, we have the nonmetals, and we have what are called the metalloids. Okay, each of these groups have a specific set of properties that determines whether or not something can fit within these groups. So if you're a scientist and you're out in the field and you run across something and you know, okay, is this a metal, a non-metal, metalloid, you can look at a certain number of properties and just make that determination right there in the field. So what properties are we going to look at? Well, metals, nonmetals, and metalloids, M, NM, and ML, are classified by their physical properties. Physical properties are measurable characteristics that describe the physical state of something. Okay, not how it reacts, but how it is naturally, how you can see it, sometimes smell it, sometimes what it feels like, and a couple of other things that you can measure without changing the substance. So we may have five main things that we look at for these types to put them into the groups. The first is called luster. Then we have conductivity, malleability, ductility, and the state of matter that they are at room temperature. So these five things are going to be tested for each substance to see which category does it fall under. So let's talk about luster. Luster is the way that a surface of a mineral or a thing shines. So how it reflects light. We can have things like metallic, milky, silky, dull, glassy, or resinous. So we'd have like metallic right here, okay, in this area. We could have kind of this shiny, glassy look here. We have resin, which is like tree sap. Things like this can all be different types of luster. So kind of like think of it like this, a shiny versus not shiny or dull luster. Next would be conductivity. This is the ability for a substance to transfer heat or electricity through it. So is it good, is it bad, or is it kind of in between? So an insulator would not be a good conductor of electricity and heat. Conductors are good conductors of electricity and heat, and semiconductors are kind of in the middle. So these are three different categories we have to be able to classify something into based on this. Moving on now to malleability. Okay, malleability is the ability for something to be reshaped without breaking. So if we have peanut brittle and we hit it with a hammer to make the candy, it breaks into pieces. Okay, as soon as you hit it, it smashes, it cracks, it breaks apart. This is what we call brittle. But metals, or things that we can hit with a hammer real hard and have it change its shape without actually breaking, this is what we call being malleable. So this is important to realize the difference of in determining whether something is a metal, non-metal, or metalloid. Next, this one's a little bit more difficult, called ductility. So ductility is the ability of a substance to be drawn out into a wire. So if I have a substance, let's say it's in like a bar shape, can it be pulled out and made into a wire? So this is very similar to malleability, but not everything that's malleable can go into a wire. But usually how this works is we have a substance and we have something that's called a die, a draw plate, and what happens is this material is squeezed through. It's larger on one side than it is the other, and so as it's being pulled through, what comes out one side is thinner than what is going in on the other side. If you can do that without breaking, then we have something that has ductility. Okay, so looking at all those things, now what classifies something as a metal, non-metal, or metalloid? So those are mainly four physical properties that we look at. Now, then one, like state of matter that it's in at room temperature, this gets a little more specific, and we're going to talk about this with metals. So metals are classified as having these sets of properties. One, that they have a shiny / metallic luster. They are malleable. They can be hit with a hammer and not break. They conduct heat and electricity very well, and usually they are solid at room temperature. There is one exception, and that is in the picture right here. This is a metal called mercury that is in its liquid state. It is melted at what would be considered normal temperatures. Okay. Now, some metals are magnetic, but that is not a property that makes something a metal or a non-metal. It's just something that we can run into as a physical property as well for most, or at least a few metals. Alright, as we keep going, non-metals, okay, these can be classified as having a non-metallic luster. They're very dull, kind of like in the picture, this charcoal. They can be brittle if they're solid, so if they get hit with a hammer, they're going to break into a whole bunch of powdery pieces and smaller pieces. Also, they do not conduct heat and electricity very well at all. They're great insulators. And these can actually be found as solids, liquids, or even gases at room temperatures. For instance, the non-metal hydrogen is a gas at room temperature, whereas carbon is a solid. So there's many different examples of this, of the different types of states of matter throughout the non-metal category. And then let's come to our last group. The last group, which is the metalloids. Metalloids are classified as having kind of either a shiny or dull luster. They can be malleable or brittle, and most of them are considered what we call semiconductors. They don't conduct as well as the metals, but they conduct better than the non-metals, and usually these are all solid at room temperature. So the metalloids are all found in one particular area of the periodic table: boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. All of these are metalloids. What's interesting here, and what makes these the most difficult to identify, is that you have to look at every set of physical properties to determine if something's a metal or metalloid. You can't go by just one alone, because a metalloid could be shiny but also brittle. Well, shiny is a metal property, brittle is a non-metals property, so we have a mixture of these. So metalloids tend to have a mixture of both metal and non-metal properties within them. So this is how we can tell them from the rest. There's only a few. There are not that many. There are way more metals than any of the other types. There's also more non-metals than metalloids. So it's important to realize how to tell the difference between one and the other, and then of course a metalloid, which is kind of like a mixture. So you have to know your list of the properties for metals. You have to know the properties for non-metals, and if you get a mixture of like both going through, then we have a metalloid. That's very, very important to remember. So with that being said, that's going to kind of wrap up this beginning thing on physical properties of the metals, non-metals, metalloids. So what I want you to do is I want you to not, okay, you do not have to do the questions or summary sections for homework for this video, those of you who are in my classroom. What I do want you to do is on the next blank page of your journal, I want you to do a small activity for me. I want you to choose 5 items, okay, 5 items from your life. It could be at home, at school, whatever. And I want you to choose these 5 items, and I want you to first name what they are. Okay, so if it's like a chair or a table or a toy or something like that, name it. I want you to describe its physical properties based on the ones that we've talked about. Its luster, its malleability, its ductility, and then of course its conductivity. Describe all 4 of those for each item. But then I want you to identify it as a metal, non-metal, or metalloid based on those physical properties. So we're going to do some identification to go along with our notes today, and that will count as our processing, you using your information in some kind of fashion. So nice and short and sweet, everybody. This is going to be it for today. This is going to be formation of, I'm sorry, not formation, but this is identification of metals, non-metals, metalloids. Just a quick overview of their properties. These properties are going to be used in class, and we're going to be working with them on and off throughout the next few days to few weeks. So hopefully these will become more second nature to everybody. But anyway, thank you so much for coming in and tuning into this next video. Again, short and sweet, right and to the point. We'll see you next time. Those of you who are in class, I can't wait to see you there. And I will see everybody next time. And take it easy. Peace.